Good day, teachers. To start with this presentation, let me ask you these questions. Do you know on what day you were born? Do you know what day we will be celebrating this year's Christmas? Can you predict the day when year 2022 will officially start? There is actually a way for us to easily determine these days. Let's discover it with ourselves as we go on with our topic this afternoon. Our topic for this afternoon is Perpetual Calendar, presented to you by yours truly, Navasi Barda. What is a perpetual calendar? A perpetual calendar is a calendar valid for many years, usually designed to allow the calculation of a day of the week for a given date in the future. Let's have a hint of history. Around 730 BC, Romulus, the legendary founder of Rome, is said to have introduced the calendar consisting of 10 months, comprising a year of 304 days. His successor Numa is credited with adding 2 months to the calendar. Then, Julius Caesar changed the Egyptian calendar, which was based on a year exactly 365 days, to a new calendar, the Julian calendar, with a year of average length of 365 and 1/4 days, with leap years every fourth year to better reflect the true length of the year. However, more recent calculations have shown that the true length of the year is approximately 365,2422 days. As the centuries passed, the discrepancies of 0.0078 days per year added up, so that by the year 1582, approximately 10 days had been added unnecessarily as leap years. To remedy this, in 1582, Pope Gregory set up a new calendar. First, 10 days were added to the date, so that October 5, 1582 became October 15, 1582. It was decided that leap years would be precisely the years divisible by 4, except those exactly divisible by 100. As an example, the years 1700s, 1800s, 1900s, and 2100s are not leap years, but 1600s and 2000 are. The Gregorian calendar, now used throughout the world, is so accurate that it differs to the true year by 0.0003. In dealing with calendar dates for various parts of the world, we must also take into account the fact that the Gregorian calendar was not adopted everywhere in 1582. In Britain, it was adopted only in 1752, and by then it was necessary to add 11 days. Japan changed over 1873, the Soviet Union and nearby countries in 1917, while Greece held out until 1923. These are the assigned numbers for the months and days of the week. Since the days of the week form a cycle of length 7, we use a congruence modulo 7. We denote each day of the week by a number in the set 0, 1, 2, 3, 4, 5, 6. Setting Sunday equals 0. Then your Monday is 1, Tuesday 2, Wednesday 3, Thursday is 4, Friday 5, and Saturday is 6. And for the months we have March is 1. because since a leap year adds a day to February, we will count the new year beginning with March 1. So our 1 is March, 2 April, 3 May, 4 June, 5 July, 6 August, 7 September, 8 is October, 9 November, 10 December, 11 January, 12 is February. To find the day of the week of any date of any year in the Gregorian calendar, we can use this formula. W is congruent to K plus 2.6m minus 0.2 enclosed in a bracket minus 2c plus y over 4 plus c over 4 modulo 7. Then our W stands for the day of the week, K is the given day of the given month, M is the number code for the given month. So March as the first month and February as the 12th month. Here, January and February are considered as last months of the preceding year. This is to make February 29th, if any, be the last day of the year. This also means that the values of C and D are for those for the preceding year. So for example, January 1, 2000 would have C equals 19 and D equals 99. And for our letter C, it stands for the first two digits of the year, and Y stands for the last two digits of the year. Let's have an example. Determine the day of the week on which January 13, 2020 falls. So our K here is 13, M is 11, C is 20, and Y is 19. We will just substitute our given values for K, M, C, and Y to our formula. So we have now W is congruent to 13 plus 2.6 times 11 minus 0.2 minus 2 times 20 plus 19 plus 19 over 4 plus 20 over 4 modulo 7. Then simplify, we have 13 plus 2.6 times 11 minus 0.2, that is positive 28, minus 2 times 20, that is negative 40, plus 19, plus 19 divided by 4, that is 4.75. We will only take the whole number value quantity, that is 4, plus 20 divided by 4 is 5 modulo 7. So we have now W is congruent to 29 modulo 7, and that is 1 modulo 7. Thus, January 13, 2020 falls on Monday. So note that the bracket symbol denotes the whole number value quantity and not the rounded off value. For example, 23 divided by 4 is 5 and not the rounded off value, which is 6. Let's have another example. Determine the day of the week on which August 12, 1990 falls. So our K is 12, M is 6, C is 19, Y is 90. So we just have to substitute the given values to our formula. So we have W is congruent to 12 plus 2.6 times 6 minus 0.2 minus 2 times 19 plus 90 plus 90 over 4 plus 19 over 4 modulo 7. So we just have to simplify it, and that gives us W is congruent to 1 modulo 7. Thus, August 12, 1990 falls on Monday. For the activity, find the day of the week on which the following significant events in Philippine history and world trivial events fall. The proclamation of Tagalog as official language, that was on June 7, 1940. Execution of Dr. Jose Rizal, that was on December 30, 1986, and the sinking of the Titanic ship that was on April 15, 1912. That's the end of my presentation on Perpetual Calendar. Thank you for listening. Have a nice day and may God bless us all.